All right, in today's learning target, we're going to talk about parallel and perpendicular lines. So far we've talked about all the different forms lines can take with slope intercept, point slope, and standard form. And now we're going to talk about what happens if we've got two lines that are either parallel or two lines that are perpendicular. So let's first start off with the idea of parallel lines. So if we remember, parallel lines are two lines. I guess it could be or more, but we're just going to work with two for algebra. So two lines that will never intersect. And intersect basically means cross. So the two lines that will never intersect are two lines that will never cross. If two lines never cross, that means they will have the same slope, which is kind of nice. So if two lines have the same slope, we automatically know that they're parallel. So for example, if we look at these two lines on the right, if I go ahead and find the slope of each one, so here's a point and here's a point, and this slope is up to 1, 2, 3. So this top line has a slope of 2/3, and this bottom line is also up to over 3. Then I can say they're parallel. We want to be really careful in math of not just looking at a picture and saying, oh, they look like they're never going to cross, so they're probably parallel. We want to make sure that we have the math to back that up. So that's why we have to calculate the slope of each and say, oh, okay, yes, they're identical. That means they're parallel. Okay. So what happens if we have equations and I don't give you the graph, and instead I just say, hey, here are two equations. I want you to tell me if they're parallel or not. Well, we have to use all of our different formulas for slope in all the different forms we've used so far. Okay, so for example A, these two lines, let me move this up just a little bit here. So for these two lines, I've got y equals negative 4x plus 1 and y equals negative 8x plus 1. I need to determine the slope of each of them. So for this first line, that's in y equals mx plus b form. So my slope is negative 4. For the second line, it's also in y equals mx plus b form. So this slope is negative 8. So are they parallel? No, they are not parallel. And they're not parallel because the slopes are different. Example 2. Both of these lines are also in slope intercept. The first slope is positive 2, so m equals 2. And the second slope is also m equals 2. So since these m's are the same, or the slopes are the same, then they are parallel. And they're parallel because the slopes are the same. Okay. Now, what if we have a line, like this first one in this last example is y equals mx plus b, but this second equation is in standard form, ax plus by equals c. I know from my learning in this unit that this first line, m is negative 8, because that's y equals mx plus b, so that first line, m is negative 8. But how can I get slope in standard form? If we remember, slope in standard form is this little formula right here, m equals negative a over b. So what I'm going to do is I'm going to go ahead and put m equals, and I've got a negative sign from the equation. A is positive 24, and b is 3. And negative 24 divided by negative 3 is negative 8. And look at that, they are both negative 8, so that means that they are parallel. Slopes are the same. So we should be able to find slopes in these equations pretty easily based on all of the learning we've done so far in this unit. Okay. So example B now. Now, instead of just determining or comparing two lines, now I want us to be able to write the slope-intercept form of an equation if I give you a point on the line and I tell you it's parallel to another line. So what this is really saying is we're going to go kind of back to that point slope form first. So the first step you want to do really is write it in point slope. Then you want to convert to slope intercept. So in order to write something in point slope, we need two things. We need the point. Okay, well, I'm giving you that, -5, 2, and we need the slope. Well, if I just learned about parallel lines, if I know that this point, the line that's going through this point is parallel to this line, then that means my slope must be -7. Because if it's parallel, then the slopes are the same. So now I've got a point and a slope, so I can write it in point slope form. So that's going to be y minus 2, because I'm taking the 2 from the y coordinate here, equals, my m is -7, so -7, parentheses x, and my x coordinate in the equation is going to be that -5, but when I put it in, I'm going to make that +5. So that's my first step, okay? Well, really my second. My first was to find the slope. My second was to put it in point slope form. But the problem is saying write it in slope intercept. So that means that I have to do this math where I distribute the 7 to the parentheses. So y minus 2 equals -7x minus 35. Then I need to get y alone over here, so I'm going to add the 2 to both sides. And I get y equals -7x minus 33. That is in slope intercept form. Y equals mx plus b, so that's my solution. Okay. Another example of this, the only trickier part about this second example is that we kind of have to deal with a bit of a fraction. So I'm still trying to find my point slope form. I know that this is parallel, so I know that m is going to be 1/5. I know there's no y-intercept here, but that's okay. We don't care about the y-intercept in this problem. We care about the slope. So I know slope is 1/5. So my point slope form is going to be y minus 2, from that 2 right there in the coordinate pair, equals 1/5 from the slope, and then that -5 turns into a +5. So there's point slope form, but now I have to convert it into slope intercept. So I'm going to distribute on the right, and I get 1/5 x, and then you have to do 1/5 times 5. You can do that in your head if you want, but again, you know me, I'm a very big supporter of calculators. So you can do 1 divided by 5 times 5. You end up getting 1. So this now becomes +1. So use those calculators to help you with your fraction work. Now we're going to add the 2 over, and I get y equals 1/5 x plus 3. Okay? So 2 examples on how to write slope intercept given a point in a line parallel. Okay? So that pretty much covers us with parallel lines. That's the learning I need us to know for parallel lines. Now let's kind of switch gears and think about perpendicular. And this one's a little bit trickier. There's a little bit more we have to do with perpendicular lines. So first of all, what is perpendicular? What does that word mean? I know you've heard this before, but it's probably been a while. So two perpendicular lines are lines that intersect or cross at a 90-degree angle. Okay? So they cross at a 90-degree angle. So something like that is a 90-degree angle. Okay. And perpendicular lines have a very unique relationship with slope. If two lines are perpendicular, one line will have the opposite reciprocal slope. And I'm going to break up those words for us here. So opposite, I kind of didn't give you guys enough room for that. That word is opposite reciprocal. Here, I'll write it bigger down here. Opposite reciprocal slope. So I have two words there, opposite slope and reciprocal slope. So when you have the slope of a perpendicular line, the other line is going to be the opposite sign. So we have to change the sign. And we have to flip the fraction. And I'm gonna show you what this looks like here. So if I look at this graph right here, I've got two lines. They look perpendicular. They look like that's a 90-degree angle, but I'm not entirely sure. I need to calculate the slopes first. So for this line, I would say these are two of the points here. And that's going up 1 over 1, 2, 3, 4. So the slope of this line is 1/4. Okay, so that's one line. If this other line, the one going right here, is opposite reciprocal, then I can prove they're parallel, they're perpendicular. What I mean by that is if this is positive 1/4, then the perpendicular line would, one, change the sign, so it would become a negative, and we'd flip the fraction, so it would become 4/1. So that's what we're looking for. We're looking for a negative 4/1 here. So let's find 2 points right here and right here. And turns out I go up 1, 2, 3, 4/1. So, and that is negative. So they're opposite reciprocals. They're opposite sign and the fraction is flipped. We would want to write this as -4 though, not -4/1. But that's the relationship perpendicular lines have. So I can conclude that these are indeed perpendicular lines. They cross at a 90-degree angle because of their slopes. Okay. So with that in mind, we need to be able to do the same things we did with parallel lines. We need to be able to determine if lines are perpendicular. Okay, so for number one, I have, they're both in y equals mx plus b form. This slope is -3. And I can write that as -3/1 to help me kind of think this through. And the other slope is +1/3. So are they opposite reciprocals? Yes, they're opposite sign. And are the fractions flipped? They sure are. So we can say yes, they are perpendicular because opposite reciprocal slopes. Okay. The line here. The next one, not as easy, but still doable. I'm going to start with the bottom equation because that's the easiest one to see. That bottom equation, the slope right away, I can tell is 1/2 because it's in y equals mx plus b form. So that's 1/2. And then this standard form, I'm going to kind of bring it down here. I have to use this formula, -a/b. So I'm going to say m equals negative for my formula. A is 2. B is an invisible 1 in front of the y. So my slope is -2/1. Is that also opposite reciprocals? Yes. One's negative, one's positive, one's 1/2, the other's 2/1. So these two lines are also perpendicular. Okay. Now this last one, we now have two standard form. So we have to use that -a/b equation twice. So for this one, I'll pull him out over here. Let me move my binder over. Okay, so I've got m equals negative from my formula. A is 6. B is 2. So my slope here is -3. So it's my first slope of that first line. This bottom line, I've got a negative from the formula, a 3 from A, B is -9, so I'm going to have a -3 over -9, and if you're not sure how to reduce that, again, use your calculator. -3 divided by -9 pops up a decimal, but we can convert that to a fraction easily as 1/3. So are these opposite reciprocals? Yes, because this has a little invisible 1 under there. Negative and positive, one's 3/1, one's 1/3. So yes, they are perpendicular for the same reasons. Okay. An example of something that wouldn't be perpendicular would be like if I got a slope of 3 and a slope of 1/3 where this was positive. Well, yeah, the fractions flipped, but they're the same sign. They can't be the same sign, so that would be not perpendicular. Okay, and you'll see examples like that in the practice. Okay. So example D, now you have to be able to do the same thing you did with parallel lines, but now I have to do with perpendicular lines. If I give you a point and a line perpendicular, you should be able to write the slope-intercept form. So we're first going to find the slope. Well, if it's perpendicular, that means it's the opposite reciprocal. So I have 1/2 in the problem, so opposite reciprocal would be a -2/1, which would just be -2. So I have to do that flip and I have to make that change, that sign change. Now that I know the slope and I'm given a point, I can put it in point slope form. So I'm going to have y, let me move that over a little bit. I've got y plus 5 equals -2 x minus 4. And I got the 5 and the 4 from the coordinate and the 2 from the slope. Now I distribute to get it into slope-intercept form. And that's going to give me -2x plus 8. Subtract the 5, and I get y equals -2x plus 3. Okay. For the second problem, same thing, find your slope. In this case, it's -2/3, so my opposite reciprocal will be just 3/2. I change the sign so it becomes positive and I flip the fraction. Now I put that into point slope form. Y minus 1 equals 3/2 x minus 2. And now I just distribute and simplify. So y minus 1 equals 3/2 x minus 3/2 times 2 times -2 is going to give me a -3. And you can use your calculator for that if you don't believe me. We're going to add the 1 over, and I get y equals 3/2 x minus 2. Okay, so two things to keep in mind. Parallel is the same slope, perpendicular is opposite reciprocal. Okay? We've got one last thing to think about, and then we're going to be done here. And that's those tricky, what about horizontal and perpendicular lines? I've put these in your practice now this unit just randomly. I've put them in every learning target. I've put some of them in there somewhere, and I've been telling you guys, just you have to find a way to memorize this. Okay, so when we talk about parallel and perpendicular lines in terms of graphing, it's a bit easier. The equations kind of make it confusing, but if I give you a graph and I say create two equations that are parallel to each line and two equations that are perpendicular, we should be able to do that okay. So this first line right here, we need to write the equation of this first line. Remember, if it is a horizontal line, that is a y equals, and it's just y equals whatever number it's going through. This line's going through -1, so the equation of that line is y equals -1. Okay, that's just something we've got to commit to our memories. All right, so if I want to list some parallel lines here, a parallel line would be like, okay, what if I had something like this? That's parallel. Or something like up here. They have the same slope. They don't intersect, right? So those would be two parallel lines. And you know what? I'll do that in a different color so it's a little easier to see. So we'll do parallel in blue here. Okay, so those are two parallel lines, and the equation for this bottom one would be y equals -3. And the equation for the top one, I drew that line through +3. So there's two examples of two lines that are parallel to my original. Okay. Perpendicular now, if I want something that's perpendicular, that's at a 90-degree angle. So a perpendicular line to a horizontal line is just a vertical line. So this would be perpendicular, and this would be perpendicular. Any vertical line is perpendicular. So something like x equals 2 or x equals -4, and I could come up with more. of a line that's perpendicular. Okay. On the flip side, if I have a vertical line here, like on the right, that equation, remember if it's a vertical line, that's an x equals, so this vertical line is x equals 3. So a parallel line to x equals 3 would be any other x equals line. These are all parallel, right? I can just draw any vertical line and say, oh, that's parallel. A perpendicular then would be any line that is horizontal. So that one would be perpendicular, this would be perpendicular, so something like y equals 2 or y equals -3, etc. would be perpendicular. So the overarching theme of these two examples is that a line parallel to y equals or x equals is just y equals or x equals. A line perpendicular is just the opposite letter. So if I have y equals something and I want a perpendicular line, I could pick x equals something, and any of those would work. Okay. So with that in mind, there's going to be something I need you guys to be able to do on your practice. And that's, instead of a graph, what if I give you a point and I tell you it's parallel to either a vertical or horizontal line? Well, if I know something is parallel to x, then I know that my answer needs to be x. If I know that something is parallel to y, I know my answer needs to be y equals something. And where do I get the somethings from? That coordinate pair. So if it's x equals, it's the x coordinate. If it's y equals, it's the y coordinate. Easy peasy. On the other hand, if something is perpendicular to x, I need the opposite letter, which is y. If something's perpendicular to y, I need the opposite letter, x. And then I just pick those coordinates. The y coordinate here is 3, and the x coordinate here is 5. So that's where I'm getting those equations. Okay. And we can even say here, if you want to put this in your notes, look at this value because that's the x value. Okay. And then if you want to think about perpendicular, it's the opposite letter or variable. Okay. So this is just the kind of thing you have to commit to memory, and the visual up here should help. Knowing that a vertical and horizontal line are always parallel or perpendicular, that should help. But this is something that we have to kind of commit. And we've been seeing these throughout the unit, and hopefully with this practice we can kind of get pretty solid at it. Okay, that's it for 5.5. Good luck.